Hey everyone, thanks for joining us for the next session of our Ask the Expert Fabric Edition series. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer. The session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our host for today, Killian. Thanks for joining.
Thanks, Anna. And I think that was a new introduction for Ask the Expert. It was beautiful. I loved it so much. Hi, everybody. Welcome to today's session on Snowflake and OneLake interoperability. This is really your chance to get all of your questions answered related to how this integration actually works and get guidance from the experts on actually how to implement it in your own organization. My name is Killian Mitchell. I'm a product marketing manager here at Microsoft. I'll be hosting today's event, but we also have Dipti and Josh from the OneLake product team. We have GRJ and Soren from the Snowflake team, along with Matthew and Eric in the chat. So we have a ton of people here, the experts in their field, to answer all of your questions. And in a few minutes, I'll bring them onto the screen to introduce themselves. But first, I actually want to spend the first 5 to 10 minutes providing a quick overview of OneLake in general and how the interoperability with Snowflake actually works. And then after we set that groundwork and let all these people join us, if they're running a little late, then we'll bring on our panel of experts who will then answer all of your questions, both in the chat and live here on video as well. So now is the time. You can start pouring in those questions now. I'll go back to the earliest comment and start from there. So if you get your question in first, you'll be the first answered. You make sure that your question is actually answered by the experts, or you can post it anytime I'm talking or afterwards. But the sooner the better to get your question definitely answered. And to start off the 5 to 10 minute overview, I actually want to start with something that we're all fairly familiar with, which is that vast data landscape that we all have to deal with on a day-to-day basis. Most organizations that I'm working with, that we work with in general, have tens or even hundreds of different team-specific data tools that they have to work with and somehow stitch together, right? You often have to do that integration work yourself, which often leads to data sprawl, data duplication, access issues, data exposure risks for your security team, which makes it really hard for your data teams and end users to access and find and use all the data that they're supposed to, while at the same time your security teams, feeling comfortable with how that data sharing and data use is working. And instead of creating that patchwork of data marts scattered across departments that you often see, we're trying to provide a single unified access point for all your data. And we're doing that through OneLake. OneLake can help you access your entire multi-cloud and on-prem data sources in a single data lake that spans the entire organization. And I like to think of it similar to OneDrive. You know how OneDrive is connected to all of your Microsoft 365 applications on the back end, providing that seamless storage place for all your files. OneLake acts very similar, but instead of M365 applications, it does it for your different Fabric engines or different Snowflake engines or other data platform engines, or even AI tools like Foundry or Copilot Studio. So it's kind of that one convenient storage place for your structured, unstructured data behind the scenes. And with that in mind, I think I should spend a couple moments just talking about how OneLake actually does connect to all your different data sources, because it plays a really important role in how the integration with Snowflake actually works. And there's two main ways, one being shortcuts, the other being mirroring, both of which are zero copy, zero ETL ways of connecting your data into OneLake. And OneLake shortcuts enable your teams to virtualize their data in OneLake without having to move or duplicate it. They act essentially as metadata pointers. So, part of the reason we named it shortcuts is because it acts similar to, say, your desktop shortcut. It's simply a metadata pointer to wherever that data lives, whether it's in Snowflake or it's in different data sources across your data estate, or even across different OneLake domains. You can create internal shortcuts as well. We also have mirroring, which is a no ETL way to bring in your proprietary databases, data warehouses, catalogs into Fabric as well. And depending on the data source, mirroring either replicates the entire database and keeps it in sync in real time, or it just replicates the metadata into OneLake in Delta Parquet tables so that it's ready for analysis. But the actual differences between shortcuts and mirroring don't really make a big difference, right? They're both no ETL ways to bring your data into OneLake that you can get started with really quickly, right? You don't have to spend the hours creating the kind of complicated data orchestration to bring into OneLake. You can just easily use shortcuts and mirroring, just depending on the data source. And OneLake not only has the ability to connect to all your data sources, but also it's designed for you to access it from anywhere that you're actually working. So, and we do this through the OneLake catalog. The OneLake catalog, it's been expanded over the past year, right? It started as just a place to discover your data. Now it's a place to discover your data, govern that data, secure that data. And we've embedded it in all the apps that people tend to use every single day, like Microsoft Teams, Microsoft Excel, AI tools like Copilot Studio, AI Foundry. And so in Excel, like say you work in Excel, you feel more comfortable in Excel, you not only get like a simple OneLake connector, you actually get the full OneLake catalog experience embedded in Excel. So if I'm in Excel and I'm trying to find the OneLake data source, I get a mini version of the OneLake catalog where I can search through everything and find the data source that I need. So it's a really convenient way to have data access across all the different apps that your business users tend to use every single day. With that context set on OneLake a little bit, obviously we went through it very quickly and it's just a high level, but I do want to kind of dive into the topic at hand today, right? Which is how does OneLake actually integrate with Snowflake and other Iceberg sources in general? And how we're doing this is partly because we've actually expanded support. So we started with Delta Lake format, support for that open format, and we've expanded it to Iceberg as well, which means that we were able to build bidirectional integration with Snowflake over the past few months. So you can create and manage tables, Iceberg tables directly in OneLake and access them from both Snowflake or Fabric, depending on the engine you want to use, and all without moving that data or duplicating that data. It's a single copy. So in other words, you only have to load it once and every engine can work from the same data. And that single copy approach lets your teams collaborate on one trusted source of truth instead of scattering information across both platforms or even like segmenting who can use what platform. You get access to both platforms, but with that single copy. And some of you may not know, but next week is Microsoft Ignite. It's our massive event. We're going to announce a ton of different innovation across Microsoft. And a couple of things that we're announcing there, and we're giving you a little bit of a sneak peek for joining. So I appreciate you guys all for joining. Here's a little present. We're actually announcing some new UI in both Fabric and Snowflake that will make the integration much easier to use. In OneLake, we're adding a Snowflake branded item in preview, which will allow you to seamlessly access all your Snowflake data within Fabric without requiring further configuration. And really what that means is if you're working in Fabric, you can now see a Snowflake item there ready to use so you can bring in your Snowflake data to use in Fabric. On the other end, Snowflake is also adding new UI capabilities designed to let you use OneLake as that native storage location for all your Snowflake data. So if it makes more sense to use OneLake, but you still want to take advantage of all the Snowflake's engines, which is a common use case, you can now do that in Snowflake with their new UI. And because they're both UI and good to actually see, we have a quick 1-minute demo to play for you to actually show you what these new UI elements look like.
My organization uses both Fabric and Snowflake, and now we're starting a new data warehousing project in Snowflake for our customer loyalty program, but we want to keep our data and work streams unified across both places. Our sales, customer support, and order systems are in Fabric, and this new project needs to unify all of this data. Fortunately, with new integration between Snowflake and Fabric, we can work seamlessly across both systems. Let's start in Snowflake and see how this works. I'm going to create a new database for some customer loyalty program data. Snowflake will directly store the data for the database in OneLake in Fabric. Let's add some data to the new database. And keeping things simple, I'm just going to upload some CSV data, review the column mappings, and now my data is loaded. I can see my data here in Snowflake, but now let's switch over to Fabric. And here you can see something really cool has happened. Automatically, a new Snowflake item in Fabric has been created. This is a fully integrated item that works just like every other data item in Fabric. When I open it, I can immediately see the data that was written by Snowflake into OneLake. I can also use all the Fabric workloads with the data. For example, I can create a new notebook and even use Copilot to quickly analyze the data. Copilot, along with every workload in Fabric, is working on the same one copy of the data. Most importantly, since Fabric and Snowflake are using the same Iceberg format of the data and collaborating through OneLake, my team can seamlessly collaborate from both while always using one copy of the data. My organization.
There we go. That's really just the start of our announcements. Obviously, you saw some pretty exciting new UI elements there, but if you want to see more of what's coming in both our integration with Snowflake, but also just generally what's happening across the Microsoft Fabric platform, you can join us either in person if you already have a ticket in San Francisco next week, or if you don't have a ticket, you can just join us online for free, which is great, and join some of these sessions. Fabric actually has a ton of different sessions, but I've highlighted these 4 sessions because they'll provide a really good overview of the announcements that we have. The first one, the innovation session, that's at a pretty high level. It's going to go over all the different announcements across Fabric and Azure databases together. But if you want to just dive into Fabric itself, you can join the second session on Tuesday called Microsoft Fabric, the data platform for the next AI frontier. That's going to deep dive into just the Fabric announcements, and it's really worth checking out. We also have a dedicated session for OneLake, which Josh and Dipti, who are joining us today, are actually going to be hosting that as well. So if you like what they have to say, join us on that session. That's going to be on Wednesday. And then if you are there in person, Snowflake actually has a very cool in-person demo to check out, and that's going to be on Thursday. Okay, with all that context set, I think it's time to bring in our experts here and give them a chance to introduce themselves before diving into your questions. I already see a bunch of questions in the chat, so thank you for already putting those in. We'll go through them one by one. But Anna, if we could bring on the other folks onto the screen, awesome. Good to see you all. Maybe we can start by introductions from left to right. So Josh, you want to take us off, and then we can go to Dipti, JRJ, and Soren?
Yeah, I'm Josh Kaplan. I lead product management for OneLake at Microsoft.
Hi, everyone. Dipti Borkar, responsible for product and engineering for OneLake at Microsoft.
Hi, my name is James Rowland-Jones. I go by JRJ. I'm the Director of Product for the Lakehouse at Snowflake.
Okay. Hi, everyone. My name is Soren. I'm a product manager working on Lakehouse and Iceberg and integrations in Snowflake.
Awesome. All right, we already have a ton of questions in the chat, which is great. The first one I see is from Scott, and his question, it's more of a comment, but I would love to see some reference architectures, best practices, and case studies between Snowflake and Fabric integration. A little bit on the case study part, we're actually working on a bunch of customer references that showcase the Snowflake Fabric integration. But as far as the architectures and best practices, this might be a question, Josh, Soren, do you guys have any best practices or architectures currently available, or are you working on any?
Right now it's Docs, and there's a bunch more coming out with Ignite, and I know Snowflake's working on a few as well, and we'll keep adding to those as we learn some of these best practices. And the patterns are still very new, and we do have lots and lots of customers using them, but in general, we're learning a lot as more and more customers come on board. So we'll keep improving those docs as we also work on those case studies.
Awesome. Yeah. So from our side, like we do have some very similar to Josh said, like documents, documentation, and other things. There is a solution brief that we are right now internally just validating it with a few customers. So once we have done that, then we'll publish the solution brief as well.
But it's super
Awesome.
exciting to see the adoption and the number of customers that are using the integration, and the interest in Iceberg continues to grow as well. So the more we learn, the more we'll share as well over time.
Well, actually, on that point, Dipti, I'm curious, like, historically, major players have not always collaborated this closely to bring interoperability between the platforms. You know, there's always been connectors, but not at this level. Can you talk a little bit more about what drove the partnership to begin with and kind of what's happening in the industry to drive this level of interoperability?
Yeah, sure. I mean, over the last several years, I would say 5-6 years, most of the data, there's been a drive for open formats. And on top of that, table formats, right? So started off with Parquet and ORC, etc. But then on top of that, we have Iceberg and Delta and others. And for customers, they are starting to look at more and more data platforms. Many customers have multiple platforms, not just one. And it's very, very expensive for customers to move this data, either copy it, create multiple versions of it, etc., which is where open formats and open platforms really come in. And so we started to embrace open formats in OneLake. This journey started off with Fabric. And as we started to work very closely with Snowflake, Iceberg started to emerge as another format. We started off with Delta, and we said, you know what, we have to embrace Iceberg as well. And we've been working on this journey for over a couple of years now. We started off first with mirroring, where you talked a little bit about it, Killian, where we first started replicating data. But very quickly we said, why do we want customers to actually have multiple copies? Let's do a bidirectional kind of zero copy access. So it gives customers the benefits of making sure that data is available wherever they want it. And it's not locked in, right? And as AI use cases started to come up as well, this became more and more important to have a single unified view of the customer's data estate. So fast forward a couple of years, and here we have full, very, very rich support for Iceberg. Number one, I think there's questions about how it's converted and all. We'll talk a little bit about that. But in addition, multiple ways of making data available from Snowflake into OneLake and OneLake into Snowflake.
Awesome. Yeah, I think that was good context to set. And I know there's tons of questions in the chat, but I'm glad we started with that. All right, we have one from Toan Fung, which is, given that our Microsoft Fabric and Snowflake environments are increasingly interdependent, with Fabric pipelines, lakehouses, and semantic models consuming data from Snowflake tables and views, what is the recommended end-to-end CI/CD and source control strategy to ensure cross-platform consistency, dependency, awareness, and synchronized promotion between environments? First of all, I just want to say thanks for, hard to say all those. I'm glad we got it through. But Soren, I might start with you on that one. How can you kind of think about CI/CD and source control between both platforms?
Yeah, sounds good. So I can start, and maybe Josh or JRJ can chime in later on. So right now the integration that we have done is like really a zero ETL integration, and that works with like a single writer and multiple readers. So basically you write it from Snowflake, and then you can read it from OneLake or any other tools in Fabric, and then you write it from OneLake, and then you can read it from Snowflake. So when you write it on the whichever system you are writing it, you will use the CI/CD mechanisms and all of the data pipelines in either Snowflake if Snowflake is writing it, or if you use the CI/CD mechanisms and pipelines in OneLake if you are writing it on the OneLake side. So that's how it's really consistent. It's very clean. No one is going to basically trip on each other's data, and it works out really well. Anything to add, Josh? Or
Now, CI/CD has been a big push from the Fabric side to make sure we have on everything, and it's actually a fundamental requirement for us anytime we release a new feature that it has to be released with CI/CD. So the new Snowflake integration that Killian showed earlier was no exception there. So we had to make sure CI/CD worked on it. Now, there's CI/CD within Fabric, there's CI/CD in Snowflake, and we had to make sure the two kind of meet up. So that was the main key here, is that everything you do in Fabric is fully automatable, and that can meet up with any of the CI/CD you're doing within Snowflake to come together to be the complete picture.
Awesome. All right, I want to move on to Sam's question in the chat, which is, can you explain how OneLake automatically converts Iceberg metadata to Delta Lake when Snowflake writes to it? And then there's a second one that we can kind of touch on a little bit, which is what performance characteristics have been observed when both Snowflake and Fabric simultaneously query the same Iceberg OneLake data? Are there caching or file locking considerations? Josh, I might start with you there, but then, anybody else, please feel free to jump in.
Yeah, how do we convert? So and the nice thing with Delta Lake, which is what most Fabric engines understand, and Iceberg, which is what Snowflake's writing, is under the covers, they're the same data format. They're actually using Parquet. So there's no actual data conversion, any data copy or anything happening like that. It's just two different metadata formats, two different JSON files, essentially. And that's pretty quick to convert. It usually takes us a few seconds on the first try. And usually you won't even notice it because it's happening asynchronously in the background when there's metadata operations happening. We tend to do it on the first read, which tends to be something in the background. Then the metadata is there, unless something changes and we just do an update. So it's usually very quick. We use a service under the covers called Apache Iceberg, which, if you don't know, you don't have to know because it's built into the service itself. So any data that lands in OneLake, whether it's natively written there or it's from a shortcut, will automatically get that conversion from Iceberg to Delta Lake, and vice versa. So if you're trying to read from Snowflake, any data that's written in OneLake from any Fabric engine, whether it's Power BI, whether it's a data warehouse there, that will also be automatically converted to Delta Lake. From Delta Lake to Iceberg, so it can be used in Snowflake or any other engine that just only knows how to read Iceberg. Performance-wise, in terms of on the reads, this is an extension of the same lake-centric architecture that Fabric is based on. Snowflake is doing as well, where it's designed for multiple readers. In this case, either Snowflake's writing or Fabric's writing, so there's no real locking contention on the files itself. And then it's multiple engines, either within Fabric or within Snowflake, just reading that same copy of data. So we really don't have to worry about file contention. It's really just about bandwidth, and it's something we scale to very well.
Yeah, and the beauty of this approach is from a user perspective and a format perspective, it's completely agnostic, right? So Snowflake writes a format, Fabric can read the format. What happens in the back, yes, we use Xtable, it's all open source, it's all open, which is goodness, but you don't have to sort of deal with it or manage it, it's all taken care of for you. And most importantly, it's zero ETL or zero copy, as sort of Noah was mentioning earlier. So there's no pipelines, there's no additional costs as it relates with the actual integration of data itself.
Awesome. We have a question from Tommy right after, which is there an easy way to get Snowflake share from a third party into Fabric? Currently, I'm having to create a local Snowflake copy and then mirror that local copy. Soren, I might start with you, but again, feel free to anybody jump right in.
Yeah, definitely. So right now, there is no mechanism for so Snowflake shares are basically okay. Maybe let me take a step back. So let me explain what Snowflake shares are if people are not aware of that. So Snowflake share is when a provider who has a Snowflake account and they have Snowflake tables, they can share their data as a read-only mechanism to another customers or clients or partners, and then the customers or clients, they can query that data or those tables in a zero ETL manner, very similar to how we are sharing this data with OneLake. So in that mechanism today, when the clients or partners, they consume the shares, it's consumable only from Snowflake environments. It's not consumable from other or third-party data as well. What we are working on now, we are working on something called Iceberg shares, or we recently launched that functionality a few weeks ago. And with Iceberg shares, clients or consumers can still query that data, but it's only consumable from Snowflake. We are working on making that data available into Fabric. It's a roadmap item, but it's not available today.
I'm going to jump down a little bit here to one from Tech George AI, Could you please walk us through some specific use cases where a company would implement Fabric and Snowflake? Why would you use both data platforms? And JJ, I might start with you on this one. Like, what are you seeing just at a holistic level, why companies are potentially using both of data platforms and then, again, using this kind of interoperability? Oh, JJ, it looks like you're muted.
Yeah, sorry. Yeah, happy to chime in. I think that the important thing is you're talking about different ecosystems and where data kind of lives and where the gravity of that data exists. So in the scenario around OneLake, where customers are looking to kind of build out their data lake in that environment, and they may be using other parts of the Microsoft ecosystem and integrating through Fabric and other areas, that is a scenario where people will generate significant amounts of data and then not want to copy that data around. However, if they then want to then expand that into other domains and other lines of business and leverage, say, for example, the power of the Snowflake AI and Data Cloud as part of that ecosystem, it could be through, for a variety of different reasons, sometimes as simple as a merger or an acquisition brings on a new line of business and they were already using Snowflake and they want to integrate seamlessly with the incumbent solution, they can just connect directly in with OneLake, into OneLake, and have access to exactly the same set of data without having to go through the data duplication effort. And I think it's worth just expanding on the points that Dipti and Josh made in this area. A lot of this really comes down to things like security and governance of the actual underlying data and avoiding the perils of data duplication in pipelines. If you think about something as simple as the GDPR requirements, if you think about how that's going to work, having multiple copies and forks and pipelines of data that create a sprawl of something as simple as a customer entity, right? If you can have one copy of that data and then reference that from one central location using the power of interoperability across these platforms, then actually you simplify the data governance requirements, you increase your data freshness, and you are using just one storage location. And so you are actually also optimizing your spend as well. So there's a win-win-win here across all of these different locations. Ultimately, it really comes down to kind of customer choice, where they want to store the data and how they want to manage that and apply security and policies over that. And therefore, it is incumbent on vendors to then work out how we work together to make sure we can deliver the right customer outcome.
Yeah, I love that so much. I think that's a great long-term view. Oh, Dipti, do you want to add anything?
Yeah, on our side, actually, what we're seeing, and a little more, specifically on the Microsoft side, OneLake integrates with many different Microsoft first-party or services and products, right? Once the data is in OneLake, you might want it down in Excel, right? And so it becomes automatically available through the OneLake data hub in the catalog. You might want to use Power BI. You might want to use Foundry, for certain specific use cases, agentic use cases. So I think there's a range of use cases depending on, in terms of what JRJ said, the organizational structures and which team is using what. It gives you many, many options of essentially mixing and matching the right engine with the right use case. Fabric does have a range of engines. I think there's a question on RTI later on. You might want to stream this data, to some other location. And so it gives you that combination of flexibility, all without duplicating the data or, creating versions of the data, etc. And so there's a lot of power to that. More importantly, it will reduce your time to insight, time to market, whatever that use case is, so you get there faster without having to build a lot of pipelines around it.
Yeah, companies do choose the combination here. And traditionally, that has led to silos of data. And that's the big change here is we're all able to interoperate. You're able to pick the right engine for the right job. You're able to produce a unified lake that can be consumed by n number of places and number of engines without creating those silos.
Yeah. Yeah, what we are seeing is mainly, customers or the enterprise data teams in customers organizations, they want to have like a single copy of data, single governance for that data, and then they want all the business units to have just use your engine of your choice. Like, you have complete freedom. So this enables all of that.
Yeah, and Dipti made a really important point about AI. What do you need in the world of AI and in the agentic workloads that we're seeing? You need to have direct access to data, right? Because in order to be able to fulfill the workload requirements, right? A SQL engine is going to be one sort of scenario, but there are plenty of others. There are other Pythonic experiences where people are going to want to be able to have direct access to the data. The disaggregation of the tables from the compute engines has been one innovation in the world of separation of compute and storage. This now takes that to the next level by enabling people to actually think about the tables as a disaggregated, open, and interoperable unit in their architectures. And therefore, the next stage in that journey within Iceberg has obviously also been the creation of catalogs and open interoperable standards around things like Iceberg REST catalog specification and the Polaris REST catalog specification, right? And that open catalog interoperability is another disaggregation. Many moons ago, there was a paper written called Turning the Database Inside Out. This is a very kind of a logical way of thinking about it, right? We are disaggregating the database kind of concept and RDBMS into all of these different kind of component models so that you can have an interoperable ecosystem and bring the right compute power to the data whenever you need it, using whatever engine you need in order to provide the best experience.
I love all that. I think also just an easy win, because oftentimes, like when you're thinking about this, integrating two different platforms like this, it's nice to have an easy win. Like the thing I often see first is just enabling direct lake mode in Power BI. So if you're a Snowflake user heavily using Power BI and you bring that data into OneLake, now you can access direct lake mode and have, always up to date Power BI reports at your fingertips. So that's an easy first win, but then obviously you get all the benefits that everyone just shared. Okay, I want to go back a little bit to Sam's question, which is, will the mirroring feature eventually support bidirectional sync, aka push updates back to Snowflake rather than just a read only? Josh, I might hand this over to you. What do you think? Are they gonna beyond just the reading of it?
Well, what I would say is we have bidirectional sharing today. That's what we've enabled here. So any data that's available from Snowflake is available within OneLake. Then any data in OneLake is available within Snowflake. And Snowflake has a feature, forgive me if I get the name wrong, it's the database link catalog.
Catalog link databases.
Catalog link databases, which will essentially sync the metadata back from OneLake in the same fashion. So you do get that bidirectional capability right now to write in one, read in the other, write from the other, read back in the original.
Yeah, and I think it's important to distinguish between mirroring and the shortcut approach, right? Because sometimes, folks might get a little more confused between the two. The initially mirroring was about replicating and physically copying the data in, right? Which is an option for native Snowflake tables, which may not be in Iceberg today, right? And to make it accessible downstream. But increasingly, as more and more data is in Iceberg, it already has that bidirectional link, which is available through that direct access. There's a new Snowflake experience, right? Killian, you showed the demo earlier. And so this experience will allow for that item to be fully integrated into Fabric and Fabric CI/CD, et cetera, and directly be used for writes by Snowflake. So the bidirectional is available, if you will, without stealing Ignite thunder soon enough. But there are other options depending on how you're managing your data in Snowflake. So native data versus Iceberg data, there's a couple of different options.
And bidirectional is available now. The stuff coming at Ignite just makes it even better.
Yeah, we are getting, I'm just going to summarize some of these questions just because there's a few that are kind of touching on the same points, which is, basically, is there a difference between accessing internal tables in Snowflake versus external tables? And is there a difference between how you actually integrate that into OneLake and then Fabric in general? Soren, I'll hand this to you.
Yeah. So internal Snowflake tables are basically the tables which we have had for like many years. These are in the Snowflake proprietary format. These are queryable only from the Snowflake environment, because nobody else engines will understand that format, right? Iceberg, on the other hand, is an open format which many other engines or many other tools can understand, right? So this bidirectional sync, or this bidirectional logic, which is a zero ETL integration, can only be achievable by Iceberg tables, because by nature, like, they are just open format tables.
Yeah, that makes sense. Thank you. Sam actually is touching on something that I was waiting for it to come up. I was interested in it coming up because while this interoperability is great, I could see security being top of mind. And his question is, how do Fabric's One Security, which is now called OneLake Security, and Snowflake's native RBAC row-level policies align? Is there kind of a future roadmap there? Dipti, I know we were talking about this on Friday. You want to touch on this a little bit?
Yeah, I'll get started, and we'll invite everyone else to jump in. Yeah, security is really important, and it's very important that we jointly figure out the interop at that level. We were talking about open formats and how they've emerged, and there's a couple that continue to stand out. Great. Now our data is open for customers, right? That was step one. Making locked data open and available in open formats, open table formats. Now, if you add security on top of it, whether it's RBAC, FGAC, whatever you call it, OneLake security, there is a approach to kind of lock that in again, because only one system or one platform can understand it. That's where interop with security principles becomes really important. And with Microsoft, we actually had this problem within our own platforms. We have many, many engines within Fabric. And so we had created a problem for ourselves. And so what we decided to do is take the security from the engine level down to the lake level, which is OneLake security, and add row level, column level security at the OneLake level. Now, when you what we want to do is expose this and make it bidirectionally available to other platforms as well, in addition to our engines. And that is something that we have been discussing, so that the data continues to stay fully open, along with the policies as well. And Josh, you maybe talk about, or others, GRJ, in terms of the specifics or any additional details.
Yeah, Jay, sorry, if you want to jump in first, or I can go. So sure. We can talk about also the partnership we're working on with the Iceberg.
Exactly, the open source.
JRJ, you want to talk about like the
polarity? I was just going to say, I think there are two levels here that I think Dipti touched on as well. There's RBAC, or role-based access control, and then there's also fine-grained access control. And so we are very active in the community, as are Microsoft and others in the community, to advance proposals especially around fine-grained access control, because historically that is the component in the database engines. If you go back to the turning the database inside out, that's the part that's been locked into the compute engines, is actually the fine-grained access control. So how do we actually enable that at almost like, shall we say, at the storage level, or for Microsoft to be at the OneLake level, right? So that you can enable that open interoperability. And the way to do that is through the definition of open standards and actually advancing that through the community, so that everybody is participating and has an active interest in doing that. Once those proposals sort of come through, then you'll start to see those things getting productized in a way that is fully embraced across the ecosystem, whether that's throughout the Microsoft ecosystem and out into kind of partner ecosystem as well from that point of view. And we are very interested and very actively working in that environment as well, because obviously from a Snowflake point of view, we would want to make sure that wherever the data is, we can actually apply the policies and be a responsible kind of citizen in that interoperable ecosystem. That's my kind of top line look at that.
Perfect.
Well, I'm curious on that front. Is there anything else that, and we don't have to talk about, you know, timelines or like when this might come out, but just at a strategy point of view, is there anything else that you're looking forward to in terms of working with Fabric, or just in general in the Iceberg open source community that you're kind of thinking about in the future? Like, where do you think this interoperability will go over the next couple of years?
Yeah, I think the reality is it just started.
Yeah.
You know, we had 5 engines on our side, at least, that we had to get to work together. And then now it's expanding that outside of Microsoft. And we kind of just got to the point now where we have really 2 standards that we interoperate over, and it gets us sharing of data. But there's a lot more. There's more metadata. There's security. There's views. There's all kinds of things right now that go beyond just the sharing of the tables, and that's kind of the next frontier that I think we're starting on together.
Yeah, and if you think about, databases have been around forever, right? 1970 was the first paper that was written. The concepts that have been added to databases, typically when you have indexing, views, there's a lot of extensibility that applies on top of tables, right? And what the table formats did is do a first pass on making sure that the basics of a schema, a table, etc., were mapped in metadata with these table formats. But there's a lot more to go. And Iceberg today doesn't have a great way of saying, okay, here's the index of this data, or here's a view on this data, or here's the security model of that data. And so Iceberg itself needs to be made a lot more pluggable, a lot more extensible. And so the community, we are jointly working, we're excited about this collaboration with Snowflake and others in the community to take that journey, right? And make Iceberg and a lot more extensible so that the higher order abstractions can then be applied on top of the table to make it more performant, to make it more optimized, to make it more interoperable, whether it's security, whether it's views. Next, we'll go to, indexing and so on. How do we know that this is an index, and how does Snowflake understand that this is an index in OneLake? There's no way of sort of pointing that out today. And so it's quite a long journey. I mean, databases and data warehouses took time to get there, and open formats and open lakes will take some time to get there. But that's going to be really important, especially for these agentic workloads, models, etc., so that they can apply on top of all data, not fragmented data, right? So fragmented data worked okay for now because you had individual apps working on individual systems, but not anymore. I mean, with agents, you wanted to leverage all data very horizontally. And so there's a sense of urgency actually now, I would say, to make it even more interoperable.
Yeah, I would add, basically, I would echo Josh's point. Like, we are just getting started. So think of it as an architecture, like or a layer that, we are having interoperability at the bottommost layer, which is the storage table format. With the APIs, now we are going to add a little bit more interoperability at the catalog level. But then slowly we want to keep just going up at higher level, as Josh said, right? Like, we want to add interoperability at the views and the metadata and so many other things. But then governance is a big point, right? Like, where as Deepti mentioned, like, there are governance policies in Fabric, there are governance policies in Snowflake, can be interoperable. So we will just keep making our way up. And we really see, like, Polaris as one of the ways where Apache Polaris is one higher level capability than the storage format. We are working very closely with Microsoft and many others on the community as well.
Well, and on this note about upcoming roadmap, Sam has a question here, and I think the answer is TBD in the future, but we can open it up to the team, which is, could Snowflake Cortex and Microsoft Fabric Copilot interoperate? Got it. Allowing natural language queries across both ecosystems. Any thoughts there long term? And I also know, like, if basically no, it's kind of TBD. I know there's some Cortex Copilot integrations as well. So JRJ, I might leave this one to you, or at least start with you.
Yeah, I mean, I think at the moment we're focused very much at the data level and thinking about the connectivity and providing a physical layer. So in Snowflake, you create something like a catalog link database to essentially enable catalog federation scenarios. But what does that do is it connects any catalogs that you have together and starts to create a picture or a view of all of the different sort of the physical layout. On top of that, then you can then build semantic models, MCP servers, and everything else that then enables that seamless execution. So the level of interoperability between, say, for example, Snowflake and Fabric at certain levels will depend on on the workload scenarios that you're trying to drive. Ultimately, for example, an MCP server is another kind of area that's sort of like a de facto open standard. And there'd be nothing to stop someone being able to stitch together integrations across MCP servers as an example of how they could do that today and get access to the same set of data, whether it is from Snowflake, either as a Snowflake table, whether it's an Iceberg table, a hybrid table, or a dynamic table, all the way through to anything that is in OneLake and exposed in other proprietary databases, say, for example, in an Azure SQL database, right? Those levels of abstraction exist in the ecosystem today, and you can build on those right now. I'm sure there will be deeper kind of integrations over time between Cortex and Fabric Copilot. But I think really what we're focusing on here is that data level levels of interoperability to enable those standards to evolve over and above where we sit today.
Yeah, the simplest answer to the question, just speaking from the data layer, we let you unify today. Either you unify together in Snowflake, the Fabric data, or vice versa, everything in OneLake. So if you're going to build Copilot or a Fabric data agent, it's going to work over both sets of data that's there, as it's all unified, and vice versa.
Yeah, love that. All right, actually, and if you don't see your question answered, I might have skipped it. I'm usually skipping the questions that I think we've already answered, but if you feel differently, just pop it in the chat again, and we can address it again more specifically. All right, question here from Sheila. What storage mode is typically used for semantic models using tables from Snowflake? I think the overall Snowflake plus Power BI integration is probably top of mind for a lot of folks, given that's a pretty common use case. So Josh, I might start with you. What storage mode is typically used for semantic models using tables from Snowflake?
Well, I mean, the typical answer for anything is going to be import mode. But the direction, the newest kid on the block and the direction we've been moving has been Direct Lake, where Power BI is able to work directly off the data that's stored in OneLake without another import, without giving up all the great features of import. And that's kind of the evolution of what we would call direct query, is this Direct Lake model where we work directly off the files in the lake. So that, like I said, the newest kid on the block there, but that's the really where the investment's going to make sure that Power BI works really well off any data that's in OneLake, and you can automatically just point to it and start using it without setting up an import. And you get that same fast performance and memory that you would have with import.
All right, here's one from Cookie Moscato. Has the collab between Microsoft Fabric and Snowflake fixed any practical issues like connection setup reports, pipeline ecosystem flexibility issues, latency, potential skill gaps, etc.? A lot to cover there. I think we hit on a lot of this already. Does anybody have anything? Is this sparking anything for anybody that they want to talk about here?
Yeah, I'll say that we've looked at the drivers and things like that, and there's some improvements that we're working on. We get a lot of good feedback from the Snowflake team in terms of performance of the drivers and moving to high performance drivers and driving that connection, improving that connection setup, etc. There's a lot of things that are in the works. I don't know the specifics of when things are going to be coming, etc. But ABFS, for example, is one of the drivers that we have improved thanks to Snowflake feedback. So it's not just the storage level integration. The relationship is beyond that, right? And there's the Snowflake team works with our AI teams. They work with our data integration teams, etc. And we do look at it holistically across the board. One of the things that we've added is in the data integration side is something called copy job, which actually does incremental copies from Fabric to Snowflake if people want to distribute that data continuously. So there's many different options of making data more interoperable, whether it's mirroring, whether it's shortcuts, whether it's natively writing to OneLake, as we talked about, or whether it's a copy job and some of these other newer areas of investment on the data integration side. So the partnership is very rounded and not just around storage.
Mm-hmm. I would like to add, the partnership here or the collaboration is actually a big step in fixing all of these issues, because the way the integration works is once you set up a connection between Snowflake and Fabric, then that's all you need to do. Like you don't have to think about building any other pipelines or anything. You create a new table in Snowflake, it automatically shows up in Fabric. You create a new table in OneLake and it automatically shows up in Snowflake. Like all the complexity and everything just is taken care of behind the scenes.
I would also just say, give us feedback, right? If the intent and the spirit of what we're doing here is to create like a first-class experience between Snowflake and Microsoft Fabric and the OneLake team in specific, but in general, to Deepti's point, it is kind of a much broader collaboration between the two organizations. If there's frustration or friction in that integration, please share the feedback. Let us know. We're here. We have thick skin. We're here to learn as much as anything else, and so we can improve.
Yeah, plus one on that. I mean, I often feel like I hear from customers that it's hard to reach us, but we have the Fabric community conferences, we have our Ignite conferences, Snowflake has their own conferences, we do events like this, all of which are great opportunities to just give us your feedback. Like we want to hear from you what's working well, what's not working as so well, what you want us to focus on in the future. Obviously, we talk about security, but I'm sure there's other areas that we could focus on in the future. So big plus one to that. Okay, we have one, and sorry, I actually just lost it, but it was from Cynthia, which is, so sorry, it's gone. Oh, if we have Snowflake as our data warehouse, does that lower the amount of Fabric capacity we need? And I actually might just broaden this to more just thinking about price holistically. If I'm using both data platforms, how can I optimize cost? Deepti, might start with you. We can switch around to other folks too, but how do you think about price when it comes to using two different data platforms, and especially when you can use one copy between both of them?
Yeah, absolutely. I mean, number one, your storage costs will certainly be lower because you don't need two copies of your data. Your costs around pipelines, maybe you were using a Spark job, or maybe you were using Data Factory, something else to actually copy that into the Microsoft any platforms. All of that goes away. And I think there was another question around, compute on mirroring, etc. When you mirror the data, we actually bear the storage costs for free on the OneLake side to some extent, and there's specifics in the documentation, as well as the compute that's related to bring it in. So overall, you should see lower costs. That's number one. In terms of capacity management, it depends on the use case, right? What is the workload that's actually running on Snowflake? What is the workload that's running on the Fabric side? Maybe it's just Power BI. In this case, if it's direct lake mode, you will save some cost on the compute by reducing the need for an engine in between Power BI and the data itself. So manage your workloads and drive the capacity across both sides depending on the demands of the workload. But overall, you should see lower costs associated with storage, associated with the actual pipelines between the two, and possibly even compute and engine compute given direct lake mode.
Yeah, I think these lake-centric architectures where you're based on open formats sitting in a lake somewhere really does change the economics all up. Traditionally, when you're looking at your data warehouse, you're thinking about, okay, what's the compute I need to actually produce my data, and then what's the compute I need to actually consume my data, all within that same data warehouse. The lake is very different. You have a mix of engines here. The producers of that data think about what do they need to produce that data. That's really all they have to think about. What do I have to do? What do I need to produce that data? And what do I need to keep that data up to date? Because my engine now is my tool for producing that data. Then you have consumers of the data, and there can be n number of those coming to that data, working on top of that same copy of data. And they really just have to think about, what do I need to consume this data for myself, for my team? And it's no longer this kind of shared exercise you have to think about up front when you're producing your data, think about also how everyone's going to consume it. So it's a very different model than it has been in the past. And whether that's just Fabric, whether that's Fabric and Snowflake, or Fabric, Snowflake, and a number of other things, the model stays, that model now is the same. How am I going to produce the data? And then what do I need to consume it?
Yeah, just to more broaden on the question specifically, Fabric is a significant platform. And so when you're talking about Fabric capacity, that could come in various forms, right? In terms of, different engine use, different storage use, where does the data come from? How does it get to Snowflake? And so, for example, the Snowflake and Power BI relationship that Dipsy mentioned before, right? So, for example, your Fabric capacity in a OneLake model where you are reading the data, managed by kind of in Snowflake tables as a Snowflake data warehouse, right? That's not going to change that capacity kind of in that regard. However, think about how the data got there. How did it get to Snowflake, and things like that. And that's where the kind of open lakehouse architectures start to kind of open up the kind of areas of possibility. And in those scenarios, yeah, maybe you don't need to kind of have pipelines that move data around. Like zero copy is a real kind of movement within the kind of industry. And so that you can avoid having multiple persisted copies of your data, so you can be more efficient, right? And in that case, yeah, then you would see a reduction in your storage, whether that was in Snowflake storage or in Fabric storage, right? That's what you're trying to achieve in that specific capacity.
Love that. I think we have time for maybe one or two more questions. One here from JR Tech, which is, how do you think managing MCP security with Snowflake? How do you think about managing MCP with Snowflake? Because I see that as an issue when creating AI agent and connecting it to an MCP server. Soren, you want to give this one a shot?
Actually, I'm not. Maybe JRJ, you want to take this one because you're more familiar with this.
So I think, generally speaking, MCP security is an evolving space, right? I mean, up until where I think we're trying to get to essentially is the notion of like pass-through identity more generally, right? So that, for example, when you think about like a request coming through, you actually can follow the identity of the requester all the way through down into the storage level. In that sense, MCP is no different to any other kind of abstraction. It's just that up to this point, the capabilities of like MCP has been a bit more, shall we say, a kind of emerging in the kind of the identity and access management kind of parts of the MCP spec. So I would say this is an area to watch as we kind of get to that level of maturity. But what we're doing is more the bottoms up work to make sure that as the MCP kind of de facto standard evolves, that you're able to do things that kind of enable true kind of like pass-through of identity all the way through the stack, all the way down to the data and storage levels.
All right, I know we're kind of running up on time. I don't want to take too much time away from you guys. Thank you so much for joining us. I do have one last question for you, which is there anything that, didn't get asked in the chat or that I didn't ask you that, you think is important to highlight about our interoperability? And it's fine if no, we hit on a lot of things.
Yeah, I think we talked about many different things. I think the key is figure out what your use case is and find the right approach, the right mechanism. There are many options to integrate Snowflake and OneLake. Now you can just directly write to OneLake and there's no sync at all. So figure that out. We're here to help in this journey and give us feedback.
Yeah, I would also just, I would echo that, but also just say, look, we look forward to meeting all of you in the community. There is one of the joys of this movement is that it is powered by open source and the open source movement and community. And so for us, we contribute there. We love to kind of meet and engage people there. And that's a great way for you to be participant in these evolving standards and be part of the journey that we're all on together.
Yeah, plus one of that, I mean, if you didn't get, because I know there's some more questions in the chat, if you didn't get your question answered, please join us in the communities. There's also a lot of docs online. Check out the docs. There's demos online. Again, we have Ignite next week, so we'll be covering these integrations in more depth in those sessions as well. So there's a lot more ways to keep engaging, and I would just highly encourage you all to continue joining our events, to continue working with us in the communities. And you'll get your questions answered there, or if not, you can at least give us feedback as well. All right. Thank you guys so much for joining. Thank you to everybody who joined us online, whether you're on Twitch or YouTube or TikTok or anywhere else. All the questions were absolutely fantastic. So I just want to thank everyone for joining us, and especially our experts here.
Awesome. Thanks, everyone. Take care. Bye-bye.
Thank you.
Thanks, everybody.
Thank you all for joining, and thanks again to our speakers. This session is part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.